So behind AI has been a very prominent sidekick, and that is machine learning. Most of us have always had the word AI alongside machine learning. So how do machines really learn? We've heard that a lot of things powering AI is machine learning. But how do machines learn? Do they go to the library like us? Do they scout around the internet looking for information and dig up all our information from our social media accounts, or from from driving data, or from our financial data? How do machines really learn? How does that process occur? That is what we're going to be demystifying in this video. So before the advent of machine learning, there have actually been some intelligence that we've been able to build into applications. In fact, almost every app works intelligently, but not the way we are experiencing today with artificial intelligence. We had traditional programming, and what is done in traditional programming is that you program the logic of the app. It's static. The app already has a very static set of rules that it goes by, and if that app needs to get more intelligent, if it needs to get smarter, you need to update the code. But all the instructions are static, and it always follows. It's the same set of instructions. The set of instructions given to it is the one it will follow. It cannot get smarter, it cannot get more intelligent, it cannot recognize data that it didn't used to recognize before. That is what machine learning brought, because with machine learning we no longer have to program applications in a fixed manner. We can actually allow our applications to learn, because this application consumes data every day. They consume a lot of data. For example, on Spotify, you are making a lot of playlists, you are clicking a lot of songs to, and it's kind of defining what you listen to. It's understanding the type of things you listen to. The same thing on Netflix, the same thing on YouTube. Now YouTube Music can suggest to you a random playlist just based off of what you have been clicking. So apps are now able to update their intelligence, and that is what AI is doing today to make applications special. And like I said, behind that is machine learning. Machine learning is what has made apps different from how they used to be before, which is follow a static set of instructions. But now applications can now get better, they can get smarter. Just like when a child grows, the child increases in wisdom, it increases in intelligence. Apps can now increase intelligently even without their code being updated. They are not programmed discretely to follow a certain set of rules, but they learn from the data they consume, and with that they can provide better experiences. So how do they learn? So our applications learn can be divided into 3 different categories, and I'm going to be going through those categories one by one. I'm going to be going through those categories one by one, and these are not textbook definitions, so I'm not going to be speaking a lot of technical jargon like you used to hear in a lot of machine learning books or machine learning lessons. I'm just going to be giving you an explanation that you can easily understand to help you to get the broad gist of how machines learn. So the first way to categorize how machines learn is based on how they are trained. How machines are trained to learn from data. And we can further break that down into 4 different ways. First is supervised learning. Now in supervised learning, you give the machine a set of data and you label them. Now let me break this down with an example. This kind of like you trying to learn a particular math formula. Let's say some trigonometric formula or the quadratic equation. Now remember those days in your textbook you're given different examples, and you see these examples, they are solved and you can see the solution. So you see a question, they give you the workings and they show you the solution. So that's how supervised learning works. You give it the data and you label the data. So more like for example, you want it to be able to recognize dogs, so you feed it several pictures of dogs, and each dog is labeled, and it's from there develops a pattern of recognizing dogs, such that once you train it with that data called the training set, after training it, when you now give it an unlabeled picture of a dog, through the pattern it has been able to come up with, it can predict what the new unlabeled dog is. So let's say you have trained it with pictures of Dalmatians, you're trained it with pictures of Alsatians, bulldogs and Chihuahuas. Aww. And you then give it a picture of a Chihuahua, but you don't tell it it's a Chihuahua. It would recognize it because you fed with a lot of Chihuahua pictures, and it has been able to define a pattern that makes it recognize that this dog is a Chihuahua. The second way a machine can be trained to learn is through unsupervised learning. Now these are the opposite of supervised learning. In this case, the training data is given to the machine without labels. You don't give the machine the labels. So the machine kind of tries to figure out its own pattern. It tries to understand what things look like, and it kind of sometimes group related data together in something called clusters. So in a process called clustering, it just kind of groups related data and tries to find different pattern among them. For example, you can give it a bunch of data of people listening to music, and it can detect that, oh yeah, 40% of people that listen to Beyonce also listen to Lady Gaga, or 70% of people that listen to Wizkid will also listen to Burna Boy. So it kind of figures out its own way of understanding and classifying the data given to it, and with that you can then use it to do things like anomaly detection, like detecting faults or detecting threats in a particular form of data, things like spam in emails, or making music or movie recommendations, as we see on Netflix. You see oftentimes on Netflix, if you have been watching a lot of Korean movies, it just starts suggesting Korean movies to you. And even if you have not been watching Korean movies, but you're watching probably Indian movies, and Netflix algorithm has detected that, yeah, a good amount of people that watch Indian movies also watch Korean movies. It can just suddenly start suggesting Korean movies to you. So that is the unsupervised way of learning. The machine kind of figures out its own pattern, and with that pattern it creates different clusters. That is one of the ways that it can work. It can create different categories of group the data into different categories and use those relationships to predict the patterns of any new data that it is now facing in production. Now, the next form of machine learning training is through something called semi-supervised learning. Semi-supervised learning. Now, this is an hybrid of the supervised and unsupervised, where you give the machine a mixture of labeled and unlabeled data. So what the machine does is that it uses the labeled data to define a set of rules. It defines a pattern. Then it tries it against the unlabeled data to see if it can predict the unlabeled data accurately. So let's use an example to define this. You remember picture tagging on Facebook. You upload a bunch of pictures to Facebook and you tag a few people. So through these pictures that are being tagged, Facebook already recognizes some people. Now when you upload more pictures of those people without tagging them, Facebook is going to be able to identify those people in those pictures, even though you didn't tag them. Just because you have once fed it information from another picture where those people exist, it has captured their facial information, and you've given it the name of those people, it can then search through other pictures that are not tagged and be able to recognize those people in those pictures. Even Google Photos does it. It kind of creates these albums of different people that you've uploaded a lot of their pictures on your phone. So that's how semi-supervised work. It uses strengths from both supervised and unsupervised learning to kind of form a pattern around the data that is being fed. Another advantage of semi-supervised learning is that anytime it makes a mistake, you can actually correct it, and it can update its intelligence. For example, let's say someone called Mark was recognized in one picture, and there's this other picture where someone else really looks like Mark, and he just decided to call that person in that other picture Mark. You can actually, like on Facebook, you can just change the tag. No, this is not Mark, this is actually Ben, and it will update its intelligence and capture more data to be able to actually differentiate Mark from Ben. So the last category under how machines are trained is something called reinforcement learning. Now this is a whole different thing on its own. It's quite interesting. Now it's similar to how babies learn how to walk. It's a trial and error form of learning. You try an action. If it is good, then you continue that action. If it is bad, then you kind of update yourself. So what the model does is that it's given a task, so it observes the environment and it decides to take an action. If that action leads to a positive result, it's going to give itself some positive marks. If it leads to a negative result, it's going to penalize itself. So with that, it kind of builds a reasoning model as to how to approach that task. And the more it does that task, the more that thing is repeated, it keeps using the information that it has learned to make better decisions until it can finally complete the task and even continue to do the task over and over and optimize it. So like I said, kind of how the baby learns how to walk. This an example can be seen in Tesla self-driving cars. These cars are given an algorithm that has already been trained from different driving data, and they continue to drive each day, but once in a while you will see a crash there, a mistake here, misidentifying an object or a road sign here, and the model keeps updating itself. It keeps updating itself. When it makes a mistake, it flags it as a negative action and updates its database to make sure that, oh yeah, don't try that action that led to a negative result anymore. But if it's a positive result, it's going to continue to use it to build its reasoning model to be able to approach that task. And even when it has been able to complete that task successfully, it's going to continue to do it to be better and better. That's how robots are eventually going to be able to master a lot of the tasks that are given to them. So that is reinforcement learning, which wraps up the first category, which is categorizing machine learning based on how machines are trained. So the second way to categorize how machines learn is their mode of learning, and these has two subcategories. That's batch learning and online learning. Now, what is batch learning? In batch learning, the machine learning model is trained up to a point and then released into production. It's released as a product, as a release. Let's say V1 is released, and from there it can't update its intelligence. It has been trained with a lot of data up to a point, and it goes into production, and it can only give intelligence up to the point it was trained. It can't learn on the fly. Now, a very interesting example of this out there is actually ChatGPT. Yeah, ChatGPT is an example of a batch learning model, because ChatGPT has been trained up to 2021, and that is as much data as it has. So if you ask ChatGPT a recent event, let's say something about Vision Pro, Apple's new Vision Pro, it can't give you any information about it. It can't give you any information. If you ask about any president, like for example, who is the current president of Nigeria, it's not going to be able to tell you, because we're currently in 2023 and its training data is only up to 2021. ChatGPT would need to be updated. The model will need to be updated to cover the amount of information up to 2023. So in batch learning, you train your machine learning model up to a point, release it into production, then you keep training it and you keep releasing updated versions, which is what will continue to happen to ChatGPT, at least for now. They might change it to another style later, but for now, ChatGPT cannot learn from new data. It has learned up to 2021 and it cannot proceed from there. Very, very soon we're going to have an update and it will be able to give us more current information. Now, the second subcategory is the online learning, and as you may have guessed, this is the type of models that can learn on the fly. They can learn as you give them new data. So as you give them new data, they continue to update themselves. They can search the web for information and update what they currently have. So they're always up to date. That is the second type of learning. I think probably Tesla driving cars might be able to do that. Yeah, they also pick information. Even all the cars are sending information to Tesla, and they're releasing all that information back to the cars that are on the road to keep updating their database of knowledge. So in online learning, your machine learning models can learn on the fly. They can continue to update their knowledge instantly without having to wait for a new release, a new patch, or a new version to be out. So in batch learning, the model is trained up to a point and released into production, but in online learning, the machine learning model can actually learn on the fly. It can learn from new information it's consuming as it is in operation. So the last way machine learning can be categorized is based on how they make their predictions. Yeah, how they make their predictions. And this can be divided into instance-based or model-based. Now, in instance-based, you basically make your prediction by comparing with the previous data that you already have the answer. Yeah, it's just as simple as that. For example, this is how instance-based works. Let's assume 70% of people in China have an IQ of over 160. If an instance-based algorithm sees a new data and that data actually comes from China, it's just going to assume that that person already also has a high IQ. Yeah, just going to assume that he has a high IQ. Or let's say it is trained with data for spam email, and it notices that 80% of spam emails always contain the word "please help" or "urgently" in their subject. If any other mail comes in and it has those words, it's just going to flag it as spam, because it recognizes that 80% of emails that have been flagged as spam contain this word in their subject. Instance-based basically makes all its predictions based on comparison. So the second category under how they make predictions is model-based, and that is the one that is mostly used these days. That's why you keep hearing the word model everywhere. Now, what happens in this form of learning is that an algorithm is fed a lot of data and it generates a mathematical equation. whether the algorithm is k nearest neighbors or k means or regression, whatever. It just generates a mathematical equation, and it is that mathematical equation that will be used to calculate the value of any form of new data. The data with which the model is being trained shapes the mathematical formula that comes out, and this mathematical formula is basically the model. The mathematical formula that is generated is the model. It contains some constants that are tweaked and refined by the data that is being used to train this algorithm, and also contains some values that are defined in the algorithm. And once you feed new data inside, it's just going to do a calculation and it's going to give you the next prediction based on that mathematical formula. So in a model-based algorithm, you simply develop a mathematical model, which is basically a mathematical function, and when you pass new data into it, it's just going to generate the prediction based on a mathematical calculation based on a model. So I hope my explanations in this video have been able to help you to understand better how machines learn. This was not meant to be a very technical, heavy explanation, but I hope you have been able to learn one or two things about how machines are being trained on data to learn and be intelligent and be deployed in all the AI features that we're seeing today. Now, if you want to know more stuff about AI, I've done a couple of AI videos that will teach you the different types of AI products we have in the world today, and even ways you can add AI to your product. So if you're interested in that, you can check out these videos for more learning. Thank you, and see you in another video.